This is engineering applications using artificial neural networks in C++ Builder. See you soon.
Hello, welcome to the AI Code Camp 2025. This is Yiilmaz Yoru. I'm a mechanical engineer and C++ developer. I have a company and I do project management. Also, I am Embarcadero MVP about 8 years, I think. Today, I will present you engineering applications using artificial neural network in C++ Builder, but most of part is about how we analyze this. So maybe you can use this in other programming languages such as in your Delphi and Python, etc. In this presentation, I will talk about AI and feature and a very simple AI application. And then I will give you some more detailed AI applications in mechanical engineering that is using thermodynamic equations and then comparing with the AI results. And there are other AI applications in C++ Builder that we code before. Also at the end, we will give some detailed informations about one of the biggest project, Embarcadero project. I'm a mechanical engineer, founder and CEO of Essential Company. We are working on energy thermodynamics, 3D designs, programming, and AI applications, and also developing some small games. I am developer since 1988. I know more than 30 different programming languages, mostly using C++, and mostly I am using C++ Builder because of its benefits. And I have many C++ posts, maybe you checked before, and developing other 3D engineering applications and gaming applications. One of the biggest AI project is our Embarcadero project. I will talk a little bit about at the end of this presentation. Here are some of our applications that we built in C++ Builder, mostly about engineering applications in two-dimensional analysis or in 3D analysis, and we have some game applications also. Now let's start with AI today and future. AI refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. The term may also apply to any machine that exhibits traits associated with the human mind, such as learning and problem solving. To the think term, you can add sense, reason, act, and adapt today. And like humans means it could be better than humans or lower than humans, but not same as humans. Human mimics and their actions. There is an artificial general intelligence term, and it is also called a strong AI. It's a subset of kernel of AI, and it is adaptive to able to develop skills. There is also artificial biological intelligence, ABI term, that attempts to emulate natural intelligence. And in general, we don't have AI yet. We have very different large scale of AI technologies now, but we have very successful results today. And there is no AGI, but the nearest AGI example could be GPT or Gemini or DeepSeek, etc. Today, AI has two different fields. Machine learning first uses algorithms to learn from data, find patterns in data, and make predictions about future events or outcomes. And we evolved this to deep learning with much more layers and much more different filtering operations. It's a neural network with the layers and filters attempts to simulate the behavior of human brain, allowing it to learn from large amount of data. So in the deep learning, we have large amount of data and a lot of layers and a lot of filter operations, different operations. So deep learning is a subset of machine learning. Machine learning is a subset of AI, and AI is a subset of computer science. Now let's look at the machine learning technologies. Artificial neural network learns from the set of input parameters and provides output when a new input set is provided. made up of artificial neurons. We call them units or nodes. Neurons are connected in neuron layers. In general, it has an input layer and output layer as well as hidden layers. And this is the very basic version of the deep learning systems, I think. And unsupervised learning is a machine learning model that deals with to find patterns and relation within the data without any prior knowledge of the meaning of data. It has interpretation, algorithm, and processing sections. And there is supervised learning. It's also a machine learning task of learning a function that maps an input and output based on the example input-output pairs. It has training, learning, and testing sections. And also there's reinforcement learning, machine learning model that can learn to make decisions through the trial and error to maximize cumulative rewards. There are environments, there is an environment and agent state, action, and rewards. Now let's look at some deep learning models. Natural language processing is a machine learning model, also deep learning model that gives the ability to machine understand and process human languages. Convolutional neural network is a deep learning model that is designed for processing grid-like data such as images, and they use convolutional layers to automatically detect patterns like edges, textures, and shapes in the data. Recurrent neural network is a deep learning model used for modeling sequence data such as time series or natural language. And generative adversarial network, there are two networks compete with each other in the form of a zero-sum game where one agent's gain is another agent's loss. They train each other so they improve themselves. Deep reinforcement learning is a deep learning model that combines the representation learning power of deep learning with the decision-making ability of reinforcement learning. And there is also generative pre-training model, which is very popular today, language model by Alec Radford and used in ChatGPT and other today's new AI models. Shows how a generative model of language acquires word knowledge from the pre-training on a diverse corpus with the long stretches and contiguous text. This is AI schematic. If we think AI is a very big field, there are AI concepts, research, and text at the outside. And if we go deeper, there is a machine learning technologies like artificial neural network, perceptron, Hopfield networks, and other algorithms. NLP and text-to-speech technologies are maybe we can count in this machine learning or inside the deep learning. And in deep learning, there is GPT, CNN, RNN, LSTM, spiking neural networks, and at the core, there is AGI. In machine learning, performance improvement by data, less than 3 layers here. And in deep learning, multi-layered neural network learns from the multi-layer network with large-scale data. And in AGI section, there might be more than those: sense, reason, act, and adapts. There are different neural network models today. This is from the Asimov Institute. You see very different neural models here, and we also know GPT is very successful. This is the example of GPT architecture, how it works. So basically all these models are similar to the artificial neural network. So if you know well how artificial neural network is working, then you can understand these models, what they are doing, how they are working together. If you look at the latest papers, and there's a artificial intelligence analyze, and intelligence index incorporates 7 different evaluations, and so there is a comparison here. So ChatGPT o4 looks 70% similar to the human intelligence, as in this paper. Today, AI technology is growing very fast, and sometimes we cannot reach new technologies. We don't understand what's going on. And for the future, there is a singularity term comes again with the AI. It's a unique event with profound consequences. Actually, there are three different definitions for the singularity. In technological singularity, some people think it's a hypothetical point in a time at which technological growth becomes uncontrollable and irreversible, and resulting in very bad situations for human civilization. And gravitational singularity is a theoretical condition in which gravity is predicted to be so intense that space-time itself would break down catastrophically. So they think universe will end in a point in a black hole or something, or it will break down everything will cool down, and at the end universe will die. And in mathematical singularity there is a function, so it is undefined. This is a very good example to singularity. And from the left side and the right side there are positive and negative improvements in y direction. If you think x is a timeline and the origin is the singularity point, then y is the results of this. So I believe AI will have good and bad technologies in the future. So it will improve rapidly more and more, as in this graphics, and then we will try to be at the positive side always. Now let's look at how AI works. I think it is good to understand artificial neural network to understand how AI works. In artificial neural network theory, there are inputs x and weights w that comes to your artificial neuron concept, and this neuron collects all this, some of them, and we give this sum to the activation function. It's a phi function generally used, and then at the end we have an output y. So this is the result of this neuron activation. So there are many neurons, many inputs. There can be many inputs: input layer, hidden layer, and output layer. So this is a basic artificial neural network model. In general, sigmoid function is used to simulate these artificial neurons, but there are many other different activation functions. There will be another presentation later. If you follow me, you can watch this later. And we are also using mean square error, root mean square error, to train and check this training and test results. And also there is normalized mean square error, which is much more precise to understand your results. Now let me give a simple artificial neural network example. There are two input neurons we have in this example and one output neuron. And what we do is we have input values here, and we multiply these values with the weights of each links. So links has a weight, and at the end we have an sum of these results, and then we give this to our activation function, which is maybe linear function or sigmoid function, and then at the end we have a result. It's an output. So it's a very simple example here, but all behind this AI technology is going like this. There are many neurons and many activation functions and weights between the links, and then they are trying to train and learn their values correctly in training, and when you ask something they give you output as a result. For example, you have a temperature value outside and inside at home, and then you want to decide if you should turn the heater on or off according to these two different temperature values. So this is a very simple ANN example for this. When you meet someone and he or she asks what is AI, and if he's not an engineer, it is really hard to explain how it works, what is AI. I found a good definition here. AI is a kind of multiplication table, so they can understand very well there is no soul or something, just a multiplication table working in a computer. So we can say AI is a set of computational techniques that allow you to solve those kind of various problems. So why AI is so successful today? Actually, we had some other methods to analyze those kind of problems before, but we were not enough to define very well some of the results and outputs. And we have a lot of regression methods in mathematics, maybe more than 20. And in those concepts, we have an input and we have some inputs, and we have assumption. If it's a linear regression, it's a linear line, maybe polynomial regression, maybe we use more complex other regression methods. But all of this has only one output, and they are not giving result very well. And when you use artificial neural network, you can have many different options as a result. You can give a lot of inputs, you can have a lot of outputs, and you can have very specific point results in these concepts. And this is why we use artificial neural network today in most of problems, because they are more accurate in most of complex problems. Generally, people are asking which programming language is good for AI. Actually, all today's programming languages are enough to do some small AI applications. But if you want to do in more professional way, I recommend you use C++. And also Delphi is very good, very similar in computation in C++. And also Python is very popular in AI sector today. It has very good libraries built in C++ mostly, so you can use Python. But in code lines, Python is slower than the C++, maybe 10 or 12 times, sometimes 100 times slower in operations. So if you go in deep and professional, I recommend you use C++. Of course, Fortran and assembler is very fast. Assembler is little maybe hard to use in this section. Now let's look at ANN applications. First, maybe 15 years ago, we had a research with my supervisor. It's my PhD project thesis actually. Application of artificial neural network method to exegetic analysis of a cogeneration system. In this project, we had a cogeneration plant of İzmir Ege Ceramic Factory in Turkey, and there are gas turbines, spray dryers, heat exchangers, and this cogeneration is a simultaneous production of at least two energy forms. It was getting input as a fuel and output was a heat and electricity. So there are many components in this factory. This is the schematic of the investigated CHP system in this factory. So there were 3 gas turbines, 2 exchangers, and 6 spray dryers. And we want to measure and know each energy parameters on each point's energy efficiency of the components. As a result, we want to find. And in this concept, we used equations, mass conservation, energy conservation, and exergy balance equations. And we define our steps, how we gonna analyze this system in thermodynamic way. And we had some assumptions in this project. And after doing those calculations in thermodynamic way, now we have input values as a parameter and we have output values. So now we can train an artificial neural network. So we give inputs and we train this artificial neural network to match these outputs. And as a result, we develop a CoGen-Next application in C++ Builder, and we had hourly data here for each gas turbine and other systems. And at the end of this project, we had comparisons of exergy distraction values that calculated from the by the fast artificial neural network and by the calculated by the thermodynamic calculations. And we had also exergy input and output values and in comparison, and we had also efficiency of the system. So AI can predict the efficiency of the system by given inputs. As you see, we had 14 inputs, 1 output, and 3 layers here, and we used 14 hidden neurons, and we had an error parameter here. As a result, we had some papers about this research, and we published this. Now let's look at second example. In this project, we had 3 gas turbines to compare each other, and we were trying to find which component is much more efficient or less efficient, so we can focus on this to improve its efficiency. So we had 3 different gas turbines to train artificial neural network, and we had output to compare. So we can compare one of them at another data set or both of them. And we had components here, so it was very important to which component needs to be focused first. So this is why we do analyze here, and we also want to see if ANN is successful as same as thermodynamic equations. So we used energy and exergy analysis. These are very simplified versions of the equations actually, and as a result we had comparison of product and full exergy results. We trained gas turbine 2 and we test on the gas turbine 3. So you see how it is very successful to find this exergy product and fuel results in comparison with thermodynamic and artificial neural network calculations. And we also did some more detailed analysis on this project. We compared exergy input and output values of each gas turbines, and we also defined the distraction, which is important for this analysis. So artificial neural network was very successful to obtain and get these results. Actually, this is a very interesting part, I think. We have more than 100 parameters, different parameters in those each gas turbines, and we have maybe 20 or 30 more different assumptions. We were using many different tables to calculate those kind of thermodynamic equations, and then as a result we had 2 or 3 or 1 outputs. and on the artificial neural network side we were only giving 14 inputs and we were comparing with the outputs. That was very interesting. That shows why AI is very useful. So maybe most of the parameters are not needed to calculate those kind of things. So AI can understand and estimate the value of the output. So it's maybe this is a mechanical engineering problem actually, but you can use in any other problems easily to solve your problems. In another example, we had a renewable energy house in Davut Paşa campus in Istanbul. The investigated ground source heat pump system is placed here, and we had a place to heat in the system. So we were able to calculate system efficiency. This is an investigated heat pump system, so we can measure each parameters inside this heat pump system. And this is the all system schematic here, including the heat pump here. So we want to know each point of parameters in thermodynamic way, energy and exergy parameters, and enthalpy, entropy parameters, and maybe if there is some missing parameters such as pressure, velocity, or other parameters, we were able to calculate here. And as a result, we develop an application, artificial neural network integrated analyzer for the heat pump systems. And we had data in seconds, as you see here. So we have about a year data, which means we had a lot of data input and we had a lot of data output in calculations, millions calculations. So we were able to calculate the efficiency of each component every second, and we can also able to calculate efficiency of this system, which is means COP. So COP values gives us idea when it is much efficient, when it is not. So we had an application and we develop another application to convert this data to a MySQL data, and then at the end we developed this application that uses this MySQL data and do calculations in thermodynamic way and within the artificial neural network. So as a result, we made comparison between the thermodynamic outputs and the artificial neural network outputs, and so we were able to see what is happening here. As you see, heat pump system is not always on, sometimes starting on and off. It's similar to refrigerator actually. It is used to heat or cool systems in house, maybe you know. And we published these results in some of the conferences. Now another application is Anabilge 2, digital assistant for the open education students of Anadolu University. In this project we had books to enter data, and to do this we developed an EPDS application to enter this data from the book for the AI. It's built in C++ builder, and it was able to connect to MySQL data with the MyDAC component. And we developed other two applications for Android and Windows again, and this time students were able to ask questions to this Anabilge, such as today's ChatGPT and other applications. And we were using Google text-to-speech and Google speech recognition APIs on the Android side, and we were able to get the data when it's asked by the students. Also, we were able to analyze student behavior behind the MySQL data here. And one of my biggest application is a Brain project. Actually, we started in 1992 with Amos Basic in Amiga computers, and then we keep developing it in C++, and sometimes we use Amiga E or other languages to test some part of codes. And at the end, we had different applications to achieve this. Still, we are developing this part, and we developed client applications, and we developed a server application. So you are able to connect personal brain data or global brain data with the client application via server application. A client application had a text input voice in Android. It was used for personal data. It's a personal assistant, and it was able to use some ANN applications. It had unlimited data, multi-language, big data support, and we were using Unicode string. Unicode strings are very useful in global way, and it is using low memory and CPU, and developed in C++ builder in FMX application. This is Abriana server application screenshot. It is able to visualize neural activation in 3D when the user requests something or when it is reading a book or reading any data. And if we look at its specifications, it has a very specific AGI-based neuron architecture and store text input in its neural network brain. And we have also AGI provides new data and assumptions from existing data, and we are storing data in a semantic way, stores Unicode text input as a semantic data online. We have AutoML feature, but not online yet, but we added this also. We have AI algorithms, some AI algorithms using inside that, and it is NLP ready. We are using REST connection. That means it can be reached by any REST application or web page. It has a fast data input and personal data model and big data business models. And also we are using a drive as a data, so it can store in your storage multilingual version. It's using Unicode strings. It has very secure neural network, we can say. It's using low memory, low CPU, developed in C++ builder as a FireMonkey application, and I think it's compatible with other assistants when it is done, and it has more AI technologies that can be added into it. We also developed a small version of it, like a small DLL or component something. It's a little version of Abriana library. It is easy to integrate with other applications, so you initialize this Abriana component first in your code line, and then you can trace, add your question or the information. That's very easy to use it, and it has REST connection, low memory and CPU usage here again, and it's developed C++ builder. And also we have many different projects actually in games, in other techniques also we are planning to use in some of bedrooms, etc. So I hope you see the final results of this project. Thank you very much. This is the final screenshot of our Abriana project when it is reading something. I hope this presentation gives you some ideas about how to develop your applications, and I hope I motivate you to develop AI applications in C++, in C++ Builder, or in any other Delphi, or in any other languages. I hope you like this presentation. Thank you.
Well, that's a heck of an opening session, isn't it? I made some notes about some of the things he said. I know Yiilmaz very, very well. Just to let you know, if you go to learnc++.org, which is one of our websites, and there's a whole guide to learning how to develop C using C++. Yilmaz wrote 99% of the articles on there, I would say, and I edited all of the articles that he wrote as well. That was one of my first roles behind the scenes before I became the developer advocate, was to be editor of most of the stuff that you read. I don't really do that so much anymore because we put out less content, but between Yiilmaz and myself, we worked a lot on that. So there's all sorts of articles, but he has always written articles about artificial neural networks, and I can tell you, some of them I had to guess they were correct, because he puts on formulae and things like that, mathematical formulas and or other things like that, and they blow me away. But a couple of important things I made notes was, and from GDK's pad as well. Thank you for the pad from the Delphi Summit. Technological singularity. I wrote that down, and he defined. Now, Yiilmaz is a doctor. He has a PhD in artificial intelligence and all these kind of things, and that's why we had him on first, because he goes into some real technical details about how this works. Now, we've got other sessions that are more high level that are like, hey, this is how to use it and all the rest of it. But a couple of things. First of all, he published his paper in 2010. That paper that he was mentioning that was part of his PhD, 2010. So a full 13 or 14 years before OpenAI or anybody else came back. He is not jumping on the bandwagon. He was there pulling away on this subject long before anybody else was doing it. That's one thing. Secondly, he started writing Abriana, which is how he pronounces it. Abrana is how it's spelled, but Abriana in 1992. I just want you to think about that for a moment. He was doing this before the internet existed, before the web came about, and was way ahead of everybody. And more importantly, Abriana, which is the product that he works on, is AGI, not AI like a large language model, which is what most of the AI you see there. But AGI it is a non-specialized general intelligence. It's artificial general intelligence, and he's still got a long way to go. He'll tell you that. It's a subject that is massive, but he does not mess around. He is a real top guy when it comes to this, and he's in demand for what he does, and really, really smart guy. But he defined those singularities. One was the gravitational singularity, where the sun gets so big that it basically implodes and then takes us all with it. And I'm sure I'll be long gone by then. We're talking about millions of years away from now, where it's inevitable that sun will turn supernova and wipe out the planet. And that's fine. It's not going to happen next Thursday, as far as I'm aware. And then I forget what the other one was, but the one that really I thought was very interesting was what he called the technological singularity. And he defined that as the point at which AI grows so large and endemic and so successful that it is uncontrollable AI. Uncontrollable. And that is the technological singularity. That's where AI gets to the point where it's everywhere, and it's so opaque. In other words, we can't see what it's doing and how it works, that we're stuck basically, and it is in charge. Now, the technological singularity is the one thing that bothers a lot of people who aren't really up on the subject, where they're going, "Oh, all this AI, we're doomed because eventually we'll just be slaves to the AI." And a lot of people will take a lot of time trying to convince you that no, it's not going to happen. It's not how it is. LLMs are large language models, and they don't, they appear to create stuff because of the way they work, but the reality is they're not doing anything intelligent. But even so, um, you know, as I mentioned before, when we were talking about large language models where they're producing code, if it suddenly makes you 10 times or 100 times or 1,000 times more productive, and the result is a lot of code, programming code that you have not written, you've got to be sure that what it's writing is good. And if you can't, then that technological singularity is coming to you very quickly in the form of code you don't understand, have no control over, and basically your business relies on that code because you ship it because it works. And then at some point a problem comes along, and then you've got to get the AI to fix it, or you're going to fix what the AI has done. So I can see, the naysayers that are worried about a technological singularity being something that is extremely possible. It's not a negative thing. I'm just saying that we should plan for it and cope with it. And so the thing is, one of the things we're going to be talking about this week is how to mitigate all this extra stuff that AI creates that we don't understand, probably. And so we deal with it. And in his Anabilga, which is the other app that he had, he also, something very important that you saw there, which again, it was in 2010 that he was producing this. It had Chat GPT like capabilities, and all the other things as well, and yet it is a neural network, not a large language model. So and Adil says hello from Agadir. Hello there. And Sylvian from France. So he was doing this way ahead of time, and I really respect him because he is an extremely smart guy, and he really knows his stuff. So fascinating video there, I think, and I'll put his website up so that you can go to it. Let me just produce that now. So let me. It is. As and his website is www.esenja.com. I think that's correct. Just check that for a second. Yes, that is correct. So that's Yiilmaz's website. So you go to he can't join us live for the chat apparently, which is a shame because I would have liked to ask him a couple of questions about some of the topics because he's been doing this a long time. Now he didn't show any examples there of code as such, but I know he has got some examples. If you go to learndelphi.org, learn C++.org, I'm just going to pull that up as well. C++ plus. Sure, that's correct. Yep. So if you give you a QR code, like this, if you scan this QR code that I'm going to put up here, that will take you to the Learn C++ website, learnc++.org. He's got tons and tons and tons of working code for neural networks and all sorts of other related topics. It's in C++. He also does some stuff in Delphi, and some of his articles are on our main website on blogs.embarcadero.com and also on learndelphi.org as well. So same as that site, except Learn Delphi instead of Learn C++. But very, very interesting stuff, and I don't pretend to understand a lot of the things that are written down on there because they just blow me away. Very interesting, but yeah, technological singularity. I mean, those of you that are live, if you want to ask me, put your point across in the chat. Do you think that AI is going to be an ongoing benefit to us, or do you think that we are actually going to be in trouble at some point? I would, if you'd asked me that question 5 years ago, I would have laughed and said, "Don't be stupid." It's not like "I'll be back," a Terminator style, and there's no way that AI will ever get that smart and we'll be on top of it. But actually, even a large language model, which is really a very narrow type of AI, and it's not even really proper intelligence. It's regurgitating in a creative way stuff that it's learned, which I suppose is a bit like a human and a child. But AGI, artificial general intelligence, is something that goes even further, and that is where it is genuinely, you don't train it on stuff, it learns, and it learns in a way that is not like an LLM. With the large language model, which is perfectly um, usable, you give it something to learn. So uh, with the things like Claude or whatever, you give it 50 billion lines of poetry, and now it can do poetry because it also has ways of understanding prompts about what it can do, and you can say to it, "You're the greatest poet that's ever lived. You are an 18th century poet, or 19th century poet living in France. Please write me some poetry in the style of, Belair or someone like that," and it will do it, and it will do it based on all the things that it has tokenized, the billions and billions of lines of code, lines of poetry. Now, the same thing's true of code. If you give it sufficient lines of Delphi code or C++ code or anything else, it will tokenize it all and learn it. Now, later on, we're going to talk about why that can be a problem. Because, for example, the big trick that people used to use was when ChatGPT first came out, because of the way that the LLMs tokenize bits of the word up. If you said to it, how many letter R are there in the word strawberry, and of course the correct answer is 3. That's right, isn't it? Yeah. No, I'm not. I just some senior moment. I'm like, wait, the strawberry spelled with 3 or 2? Yeah, no, it's 3. 3. It's 3. If you'd ask it how many letter R's there are, and it would get it wrong. And the reason is that it takes straw and berry and tokenizes them separately. And so it says there's 1 R in a straw and 2 in berry. But the way it tokenizes it, it just gets it wrong. I didn't quite understand what the magic was that went on behind the scenes, but it was just a classic example of, you're so smart, you're dumb. The LLMs were just repeating tokenized information. I also I remember when Facebook first came out with their face recognition. Little confession here. I was skeptical that it would work, and the reason is that I actually used to work in the field of time and attendance and access control, door controls, door locks, and in fact, my apartment has electric a door lock, and it's a smart lock, so I can open it with my phone and I can email it, I think, or something random. I don't know, some nonsense. I've got an app and I can type numbers in on a keypad and stuff like that. But I know how fingerprint scanning and hand scanning works. In fact, behind me on my crazy shelf of things, uh, down there, whoops, that is a hand scanner, and then that there is a fingerprint scanner. Okay, and I'm an expert on these things, and I know how they work. Now, they look a bit like they're AI, and in fact, if you were a sneaky salesperson, you could say it does AI fingerprint recognition, but no, it doesn't. It takes the measurements of all your fingers and then produces an approximation. And when you put your finger on to clock in or open a door or whatever, it takes another scan and it works out approximately how similar is your finger to the fingers it knows. And it uses a string of numbers for that. No AI involved. Okay. So when I when I when I see these systems out there claiming to be AI, I can be a little bit skeptical because I've seen these things before, and you know they're not. But what was the point I was going to make? Yes, about that access control and hand scanners. It's only a question of time before they're all you know learning stuff with AI built in, and I think that you know, the large language models are great, except they're only as good as what goes in and only as good as the prompt that you put in. With AGI, which is what Yilmaz was talking about, it's far more than that because it's a neural network. It works in a similar way, except it strengthens the pathway. So, for example, if you are learning to ride a bicycle, we believe, because we're not 100% sure, but we believe that the way the brain works is that our neurons, as you balance correctly, the more times you do that, the better you get at it, and the more pathways in your brain are strengthened, so that when your brain goes to select how do I ride a bike, those neurons are the ones that fire first, and you know how to ride a bike. And there's some certain unconscious things that go on that happen in the back of your brain, and the medulla oblongata and all those kind of things, where your ability to balance, for example, is not something you tend to consciously do. Otherwise, you'd fall over the minute you lost concentration. You wouldn't balance. Your brain has got these low end systems that take care of that, and that is, you know, the ability to learn is more like the kind of thing that Yiilmaz was talking about. LLMs completely different. They're almost pattern matching and regurgitating patterns. They are creative, but you know, trusting them is implicitly is something you need to be careful of. But that thing, that word that he came out with, technological singularity, where AI becomes uncontrollable. Like I say, 5 years ago, I would have said, No, that's not going to happen." Now, yeah, I can see the more we rely on AI, the more it can be a problem because, as I showed you in my presentation, I said to it, "Create me some slides, PowerPoint AI, create me some slides about what I need for this subject," and it did a very poor job of it, really poor, and you would think that it would do a better job. So there you go. So, have we got any questions from the people that are watching here? Because our next presentation is on the hour, so we've got about 5 minutes left. Maxi Donkey had to leave because he's still in the math lab at the university and he has to go home. Uh, yeah, Maxi Donkey, he's one of the ones that's produced a lot of those plugins. If you go to Get It Package Manager and select in there, you'll find a whole ton of packages, and Maxi Donkey is responsible for a lot of those, even though he describes himself as, "Oh, I don't really use Delphi that much." Well, he does a really good job for someone who doesn't use it very much.